Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to this Godot 4 platform tutorial video. In this video, I'm going to show you how to build a simple platformer. Here is some footage of what you'll have by the end of this video with a character that can move around, has some animations, and can handle sloped movement and jumping and everything that goes into a basic platformer. Also, I want to say that by the end of this video, or at the end of this video, I will have a special announcement. So you'll want to stick around to find out what that is. Let's get started. Open up Godot 4, and we're going to create a new project. I'm going to put this in Godot 4. I have a folder for this, and I'm going to call this Heart Platformer. I'm going to use a compatibility renderer because I'm making a small 2D game, so I don't need to have the more advanced 3D graphics. And we'll create this folder and then create and edit. Once we've got this up, we're going to click on the 2D tab right here. We're making a 2D game. We're going to add a new node right here, and we're going to call this world. And save this scene and save. Now you can technically run your game, and Godot is going to ask you what your default scene, the first scene that the game runs is, and we're going to set this to world. So we'll do select current, which is the current scene, and now our game is running. We're going to come into the project and come into the project settings. Now inside of here, we need to set up, we need to do some setup for our game because it's a pixel art game. So the first thing we're going to look for is filtering. And you can see under rendering and textures, we have default texture filter, and it's set to linear by default. But because we're doing a pixel art game, we're going to set this to nearest. And that will remove any fuzziness around our pixels, and they'll be nice and sharp. Okay. The next thing we need to do is come into our display and window settings. We're going to set the size of our viewport to 320 and the height of the viewport to 180. And that's just going to be a much smaller screen size, but it's still 16 by 9. Once we've done that, we want to set the stretch mode to canvas, but we haven't, that will make sure that the game gets stretched up, but we haven't set the window size because this is just the viewport width and height. We need to be able to set the size of the window on the screen. You can see if we run our game right now, it's just going to be this tiny little window. We want to scale it up. So inside of the project settings, we need to turn on advanced settings for this. Unfortunately, I think it should be under the basic settings. And the window width override and the window height override will set the 1280 by 720. Then we can close and run our game again. And here we go. We've got our window is scaled back up to be much larger, but the window inside of the game is still quite small. Now, to make a platformer, there are two different kinds of bodies in Godot that you're going to be using. The first one is called a static body, and that's used for the platforms that your character moves on and jumps on. And the next one is called a character body. Now there's some other bodies, but we're not going to get into those in this tutorial video. The static body, again, is for the platforms that your character jumps on, and the character body is for the character. So we're going to start by turning on grid snapping right here, this button. And on our world, we're going to add a new static body, like this. And now adding a static body adds that node to our scene tree here. So inside of Godot, you have different nodes, and each node has kind of a job. And so the job for this node is to handle a static body. But we've got an error message here saying there's a configuration warning. Well, that's because this node has no shape. So our static body needs to have a collision shape attached to it. Otherwise, it won't know how to interact with other bodies. It won't know when it's colliding, essentially. We're going to add, as a child of this, we're going to add, so make sure this is selected, click the plus button. We're going to find a collision shape. Now, there's collision polygons and collision shapes. A lot of the time collision shapes are sufficient, but for this video, I'm going to use a collision polygon. And that's because it'll make it easier to create a level, kind of like a test level, really quickly using this. Now, when the collision polygon is selected, we have these new options up here. You can see we've got this one right here for creating points, this one for editing points, and this one for deleting points. So we're going to click add points, and then I'm just going to start clicking inside of this room to create some points. And I'm going to do some that are slanted like this. Let's see. Well, we'll just come to there. It's like a city skyline, almost. There we go. And then we want to come back around and finish the shape. Now I'm going to click edit points because I want to adjust some of these. So let's move these down just a bit, and I'll move these up so they're much higher, clear off the screen like that. And that's probably going to be good enough. Now we'll save. If we run the game again, we can't see it in the room, and that's because these collision shapes are actually invisible. Your character's collision shapes, you don't want them to be visible. But if we come up here into the debug settings, we can turn on visible collision shapes. And then when we run the game, the shapes are visible inside of the room. Nice and colorful as well. However, we're going to do this a little bit differently. We're going to come into our project, come into debug, and with visible collision shapes, we'll turn that off. Now on our collision shape here, as a child, we'll add another node, and this one will just be a polygon 2D. Now, polygon 2D is just a visual representation of some polygon. You can see it can have a color, it can have textures, it can be anti-aliased if you want. Now we could go over and we could draw along our collision shape here to create a visual polygon, but we don't need to do that. We can actually use some code to do that for us. So we're going to attach a script to our world node here. We'll click on world and we'll attach a script. Okay, world. And then inside of here, we need to get access to our polygon 2D and our collision polygon 2D. And to get access to these nodes, Godot uses an onReady keyword and then stores those nodes inside of a variable. So you could do onReady var polygon 2D equals, and then Godot has a shortcut for getting access to it, which is the $, and then polygon, whoops. Yeah, that was right. Polygon 2D. Now you can see the whole path out here. You can see we have static body and the collision polygon 2D. We're not actually we're getting access to the collision polygon. So we'd have to do another / and then polygon 2D like this. But typing this out every time is kind of a pain. Instead, in Godot, you can actually click on it and then hold down and then press Control and hold down and drag it over. And it will just do that for you. So click, then hold down Control, drag it over. Now we have access to both our collision polygon 2D node and our polygon 2D node. Now at the start of the game, in our ready function, so this function right here is called right when this node is ready. So the very start of the game. We can set the polygons for this polygon 2D. So we can say polygon 2D dot polygons is equal to collision polygon 2D dot polygon. And I don't know why this one's polygons and this one's polygon, but when we run the game, no, I was wrong. They should both be polygon. Yeah, there we go. So what that does is it takes the shape of our collision polygon 2D and assigns it to the visual polygon 2D. Okay, so this is some pretty good stuff already. You're learning how to get access to nodes inside of code. And then we can set properties on those nodes or get properties on those nodes. And we've easily set up this little platformer. Okay, now we need a character that is going to be inside of this world. We're going to need our character body. Now we could add it right here to the world like we've done with our static body, but for our character, we may want to put this character inside of multiple different levels or multiple different scenes. So because of that, it makes sense to make it its own scene. So come up here, and with this little plus button, we can click Add New Scene. And if we come into our 2D scene here, we can do Other Node, and then we can search for Character Body 2D. Now we have our character body, and it's giving us a warning as well. It needs a shape. So we're going to add a new collision shape. Like this. And we'll do a rectangle like this. For now, I'll just set it using snap like that. Okay, but there's no visual representation of this character. So what we can do is click on our character body and then add a new sprite. Now this sprite node, sprite 2D node, as a child of our character body can be the visual representation of it. So we can drag over the Godot icon, which is massive, by the way. So we'll want to scale it down so it's not so big. Okay, there we go. We're going to change this in just a second. We're not going to keep that. And we'll rename this player, and then we'll save it. Now we have our character body. And this character body is saved as its own scene. You can see down here we have our world.tscn and we have our player.tscn. If we come into our world, we can actually grab the player and just drag and drop it into this world like that. If we run our game, there's our player. But it doesn't actually do anything yet, so we need to add some code. So come back to our player and we're going to attach a script. Now by default, Godot has this character body 2D basic movement template, which is just a template script that gets applied to a kinematic, or not a kinematic. It's good. That's what it was called in Godot 3. It's going to take some getting used to. A character body. And that's fine. We can start with that. So we'll just hit create, and then it's given us all this code right here. And we're going to go over this in just a second, but you can see if we run our game again, our character can move around with the arrow keys, and we can press the space key to jump. Now the movement feels really jarring, like it feels really bad, right? And that's because the default template is designed for games that are maybe a little bit larger scale. We're doing very small pixel art, so this movement feels really fast and the character jumps really high, right? So that's what's going on there. But we can come back and adjust some of these things. So let's set our speed to 100. Let's set our jump velocity to -200 and run the game again and just see what happens. Okay, now this is filling. Okay, jump velocity is probably a little too low. Let's set it to 300. But the movement definitely is feeling a little bit better. Okay? And we can actually move on these slopes, although it kind of like jumps down this one, right? So there's a little bit of stuff going on with our slopes still. It doesn't feel quite right. Okay. So let's go over the code that we have here. So at the very start, we have extends character body, and that just means that it's inheriting all of the properties that come with a character body in Godot and all of the functions that come with it. And I'll tell you what some of those are. Then we've got this constant up here, which is the speed. and that's just a place to store the speed that the character can move at, and our jump velocity. And it's negative because in Godot, y is positive going down and negative going up, so it's flipped. And that's actually pretty normal for 2D engines. As an example, GameMaker is the same. It's also negative going up for y. Now for left and right, x negative is left and x positive is right. So that's what you'd expect, but the y is flipped. Now our gravity variable here, we're getting from the project settings. You can see it has physics, 2D, default gravity. And if we come into our project settings and search gravity, and then click on 2D right here, you can see our default gravity is set to 980. And then the gravity vector, which is the direction that the gravity pushes, is by default down, although we're not using that property currently. Okay, now we have this physics process function right here with a delta argument passed in. Now physics process is a function that is run every single physics frame of your game, which by default, if you come into your project settings again and we look at FPS, is that going to be it? We might have to actually go under physics. Physics, 2D physics. No. Physics 2D. It might not be in, oh, we're already in advanced settings. So common, here we go. Under physics, common, we have physics ticks per second, which is by default 60. So every second, our physics process function is going to run 60 times. Okay? And delta is going to be how long it took between each frame, which is going to be 1/60th. Okay? I think that's right. So this function is run every single physics frame. Now we have some code right here that is applying our gravity, and we have a comment here that tells us that add the gravity, right? It says if not is on floor, velocity.y plus equals gravity times delta. So if our character isn't on the floor, and this function, by the way, is on floor, this is on floor function, comes from our character body 2D. If you click on this, if you hold control and click on this, you can see character body 2D. It has some properties and it has some functions, and one of these functions is on floor. Okay? So how does that function know when it's on the floor or not? Well, if we come into our character body 2D and then come over here, you can see there's a floor property here, and it has some information, and there's an up direction vector right here, and you can see up is -1 in the y. So it can tell when it's on the floor based on this up direction. So since the up direction is negative in the y, pointing up, then it knows that the down direction is y1 here. And so it can tell when there's a collider underneath it. So you're kind of orienting it with this up direction. And by default, it's just going to be what you'd expect, right? This way is up. But you could make a game where gravity was in reverse, and then is on floor would check above the character because your y would be pointing down, your up direction would be down, okay? So keep that in mind. This right here is going to use the up direction to orient itself. Okay, so if we're not on the floor, then we're adding to a velocity property here. Now, velocity is also in our character body. It's a default property here. You can see that current velocity vector in pixels per second used and modified during calls to move and slide. Okay? Oops, I didn't mean to press that. Hit back again. So we're adding to the y value of our velocity, and adding to it meaning going down, right? Positive is down in the y. So that's what's bringing us down. That's our gravity. And we multiply by delta so that that motion is time dependent and not frame dependent. Okay. Now handling the jump. If input.isAction just pressed UI accept and is on floor. So if we press accept, which is the space key, by the way, and is on floor, and we're on the floor, then we set the velocity.y equal to jump velocity, which is negative 300. Okay? Now, the reason we don't need to apply delta to this, because you might be wondering, why don't we times this by delta? I can type it. Well, the reason we don't need to multiply it by delta is because move and slide automatically applies delta. And we'll get to that in just a second. Okay? So here's how we jump. We're just setting our velocity to negative 300 when we press the space key if we're on the floor. If we were to remove this if is on floor, then our character could fly. They could jump in the air. Because then they could jump whenever, not just when they were on the floor. Okay? Makes sense. Okay, now this var direction equals input.getAxis. So input.getAxis is a shortcut to determine which direction the player is pressing. So we have UI left, which is like left, the left arrow key, UI right, which is the right arrow key, and getAxis is going to return a number based on which of these are pressed. So if the left key is pressed, it's going to return -1. If the right key is pressed, it's going to return +1. Now, on a controller, it might not actually be 1. It might be like -0.5 or +0.5, right? But that's not important on a keyboard. Keyboard is just you're either pressing it or you're not. There's no in between. So this will either return -1 or +1. Or it will return 0 if we're not pressing either of them or if we're pressing both of them at the same time. So then we say if direction. So this check right here is a bit of a shortcut. It's basically saying if direction does not equal 0. And I'm actually going to put that in here to make it a little bit more clear. So if it's not 0, then our velocity is going to be set to our direction times our speed. So 1 times 100. So, right, that would be moving to the right. Moving to the left would be -1 times 100. So that would be -100. And that's what allows us to move left and right. Then for our if direction does equal 0, so if we're not pressing either of these, then we're going to apply a friction. And it's using move toward here. And this is a bit weird to me as well because we're not multiplying by delta here, which I think we should be. In reality, we can just set this equal to 0 because that's essentially what we're doing anyway. Now, finally, the very last thing that happens inside of this physics process is move and slide. Okay, and move and slide, all it does is it takes our velocity and then it moves our character by that velocity while also colliding with and sliding along any static bodies that it runs into. Okay, and it obviously multiplies our velocity by delta, but this function right here, it handles all the movement and collisions in the background. So you just call it and your character will move. That's it. And collide with the stuff around it. And it makes sense. Okay, so let's do some modifications now. Now that we have a decent understanding of what's going on with our code here, we're gonna modify it and we're gonna make it our own. So if we come, first though, let's come to our character body here. And one of the problems that we have is that our character, when going down steep slopes, they jump down. See that? We want them to snap to those slopes better so they don't jump down the slopes. And this is kind of your choice as a designer, but that's how I want this game to function. And that's how a lot of kind of retro games function with slopes. Okay? So Godot has a built-in thing under the floor section of your character body called snap. And it's got this snap length. And it also has stop on slopes. So if you uncheck stop on slopes, our character will slide down slopes. Although the gravity might not be enough for it to do that. I wonder what block on wall is. The other thing okay, so let's focus on the jumping. So it has this snap length. Well, first of all, the max angle. That determines what kind of an angle you can actually go up. And you can see 45, this is a 45. That's the steepest angle that we can go up. Then we have our snap length right here. And right now it's set to 1. Let's set it to 2. And that determines how far down the character should attempt to snap to the ground. You can see when we set it to 2, we no longer jump off of those 45s. It snaps down. It has a real nice feel to it. Now our speed going up and down slopes is not constant. We go faster down slopes and slower up them, especially steep ones like this 45. Now, there's a property for that. Do we want it to be constant? I do. I think it feels better to have it be constant. So I'm going to set mine to constant like that. And now we're doing pretty good with our movement, right? We haven't even modified the code. Did I bounce there? No, it seems to have worked. Okay. Okay. Now our character has really snappy movement. We go from 0 to 100, literally, whenever we press an arrow key, right? So we can adjust that. We can make some changes. Let's add an acceleration variable to our code. So we'll come up here, const acceleration equals, let's do 400 maybe. We'll have to test these values. And then down here, instead of just setting our velocity.x, what we'll do is we'll say velocity.x equals move toward, now we want to move towards our speed times our direction, right? Oh, that's our from. So the first argument is our from. So move from velocity.x. So we're going to move towards something from somewhere. The from is going to be our current velocity.x. And we're going to move toward our maximum speed, which is going to be speed times direction, right? What we're setting it to before. But now we need to give it an amount that we move towards that value. And we're going to do acceleration times delta. Now we do need to multiply by delta here. And that's because this is, so move and slide multiplies our velocity by delta, right? And velocity is the change in position over time, okay? So we do need to multiply it by delta, but move and slide does that for us. However, acceleration is our change in velocity over time. And it is not multiplied by delta by default because move and slide doesn't actually manage our acceleration. So because of that, we need to multiply by delta here. Okay, now you can see our character kind of gains speed slowly. It's a little laggy. So we might want to increase our acceleration just a bit. So it's a little bit snappier. Our character also doesn't have any sort of friction. So we can change this to handle that as well. So we'll come up here. Const friction equals 600 as well. And then we'll come down here. We'll say move toward. Where are we moving from? Velocity dot x. Where are we moving to? 0. Right? This is our friction. And then friction times delta. Friction is just another form of acceleration. In a sense, our friction is also our change in velocity over time. And gravity is also change in velocity over time. They're just different applications of that, right? Gravity is our change in velocity over time. pulling us down. Acceleration pushes us forward and friction slows us down. Okay, now our character slides quite a bit still, so we might want to increase our friction. Now the weird values here is because speed will be multiplied by delta in move and slide automatically, but acceleration and friction aren't, so they have to be much larger. Make our friction 1,000. Okay, that feels pretty good. We've got pretty smooth movement for our character now. Okay, now we have a problem, and this problem is that our character has the same jump height no matter what, and we want to be able to manipulate the character's jump height. So what we can do is we can come into our handle jump function, and well, let's do it this way. We're gonna restructure this code a bit. We're gonna say if is on floor. So if we're on the floor, then if input.isAction just pressed UI accept and jump. Okay. Else. So if we're not on the floor, we're in the air. If input.isAction just released UI accept velocity.y equals jump velocity divided by 2. Okay, so if we're in the air and we release the jump key, then we set our velocity to half the jump height. Okay, now try doing a short jump. You can see we can, if we hold it, we'll do a much higher jump. The problem is if we release on the way down, it creates this weird double jump. So how can we prevent that? Well, on our release, we want to make sure that our velocity is not positive, because if our y velocity, because if our y velocity is positive, that means we're falling down. Okay? So we could say, and velocity dot y is greater than 0. No, less than 0. So if it's less than 0, we know it's negative, which means we're still going up. And that allows us to not release on the way down. We can do short jumps. We can do longer jumps. Now the problem is if you time it, you can get kind of like a higher jump. See that? I can get that higher jump if I time the release. And it can kind of feel a bit weird. So instead of seeing if our velocity is less than 0, what we can do instead is check to see if our velocity is less than our jump velocity divided by 2. Jump velocity divided by 2. And that will prevent us from ever getting any sort of extra height by timing it. But we can still do our short jumps. So now we have a short jump and a long jump. Okay, we're doing pretty good. Now let's organize our code just a bit. I don't like using comments like this because comments, they have their place, but I think it's more useful to use functions for stuff like this. Let's create a new function called apply gravity. This. And then inside of this function, we'll just copy this right here, this code. Paste it right here. And now we can just, instead of having a comment here, we can call apply gravity. And now this code is self-describing, right? We don't have to have a comment that says apply the gravity. The function itself says apply gravity. And it's mad at me though, because apply gravity needs delta. See how we're using delta? It says delta is not declared in the current scope, which just means inside of the scope of this function, it has no idea what delta is, because delta only exists inside of physics process. But we can pass it in. Delta and delta. So we're passing that information into this function now. So now it has access to it. Now we have our jump check. So let's create a function called handle jump. And it doesn't need delta, so we don't have to pass it in. And then we can copy this code right here. Inside of that, handle jump. Like this. And there we go. I'm going to maximize this so it's easier to see. Now we have, we're getting access to our direction. I don't like calling this direction though. I prefer to call this our input axis. So let's replace direction with input axis. And then we're going to separate out these two things into accelerating the character and applying friction. So let's start with apply friction. So we'll create a new function, call it apply friction, like this. And inside of this function, we'll say if, and we're going to pass the input axis, and we're going to pass delta. And then we'll say if input axis is equal to 0, and then we'll copy our velocity right here. Control X, Control V. So velocity.x equals move toward. It just does our friction. Then up here we can call, instead of having else inside of here, we can just do apply friction. That, and then we pass in our input axis. We pass in delta. Now last but not least, we need to accelerate the character. So we're going to call this apply, what should we call this? We have apply gravity, we have handle jump. We could call it handle acceleration, maybe. And this is also going to need an input axis, and it's going to need delta. And we'll make that function down here. Apply, no, handle acceleration, input axis, and delta. And then we'll just paste the code in here. So now our code, inside of the physics process, we apply the gravity, we handle the jump, we get our input axis, we handle our acceleration, we apply the friction, and we move and slide. So our character, our code is pretty clear, pretty clean. It might be nice to have a slightly faster acceleration still. Set it to 800. Yeah, just a little bit snappier. And of course, the values that you choose are going to be dependent on the type of game you're making and how you want the game to feel, right? All of this comes down to the specific style that you're going for and how snappy you want your game to be versus maybe slidey. Mario, for example, Mario Brothers 3, he was definitely more slidey, and like he could slowly accelerate up and then slide if he, along the ground if he tried to turn around. Now the last thing, we've already got pretty good movement. Everything's going nicely. The last thing we're going to do is import in some animations. So let's come down to our, in this video, in the description, I'll include a link that you can get access to these animations. I'm actually going to rename, we'll grab this player script. Okay, I have to extract it. Oh, I've already extracted it. I did? I don't remember doing that. Here we go. Drag the player, drop it in here. So you can just drag the sprite in and drop it. I'm going to rename it though, with a lowercase p, like this, rename. And then we come into our sprite here and we can drag in our player sprite. Oh my goodness, the sprite is still scaled though. Come into the transform and reset the scale. There we go, that's much better. And what a cute little character, right? But this is a sprite sheet, meaning we've got a bunch of different frames on this animation. And because of the type of character that we're doing, a sprite 2D actually isn't the best fit. So we're going to delete our sprite 2D. And on our character body here, we're going to add a new node, and we're going to do an animated sprite 2D. Now you can animate a normal sprite using an animation player. But for this example, it's actually going to be easier just to use the animated sprite. So once we've added our animated sprite, we can come to the animation tab, and there's going to be a sprite frames. We'll click on that. We'll do new sprite frames, and then click on that. That will open up this new thing down here, and we can create some animations. So let's create an idle animation. We can rename it. We can click this little grid thing, select our player, and it's going to want to ask us how many frames there are horizontally and how many there are vertically. Vertically, there's only 1. Horizontally, there's 8 maybe? Nope. 7. Okay, there's 7. So for our idle frame, we're just going to grab this first frame here and add it. Now let's add a new animation with this button, and we'll call this run. And we'll add a new one, and we'll call this jump. Those are going to be the only ones we have. Let's go into run. We'll grab this. Now, it doesn't remember our properties, which is a bit annoying. It would be nice if it could remember this particular sprite and what we set it to last time, but we have to redo it. So let's set our vertical to 1 and our horizontal to 7. And then this was, we were doing run, right? We're going to select all of the frames. Nope, not the last one. Everything but the last one. And then I like my, whoops, tap the microphone. I like my character to start out on an action frame. So I'm going to take this first frame, which is not an action frame, and I'm going to use these arrow keys to move it all the way to the end of the animation. Okay. Now we're going to come into our jump, do the same thing, grab our player, set this to 7, set this to 1, select the very last frame, which is the jump, and we're good to go. Now you can set the frames per second. By default, you can see that it's set to 5 and the animation is set to loop. We can use this play key to actually watch the animation. Now 5 is pretty slow. So let's bump this up to 10. And that's a much better frame rate, I think, for this animation. Okay, we'll save. Now we can move our character just a little bit. I like, with platform games, I like to have the character level with the origin. So let's hide our collision shape for just a second. We'll turn off snap. We can move the character up to where he's right there on the ground, right there on the origin. See that? You don't have to do that, but I like to do it. Now we'll come into our collision shape and we'll adjust this. We want to make sure that our collision shape matches with the character's feet. And it's going to be easier if they're not running. So let's switch to the idle animation. Whoops. And yeah, so the collision shape matches up nicely with the character's feet. And that's what we want here. Now remember at the start when we got access to the different nodes, we need to do that so that we can get access to our animated sprite and control which animations are playing. So we'll click on the node, hold down the left mouse, then press and hold down Control, and drag and drop that into our code here. Really convenient to be able to do that. We used to have to type this out every single time. Man. Now we're going to write some code that's going to handle our animations. So this is going to be, we'll just call it update animations. Come down here to the very end. And we're going to pass in an input access because we want to know whether the player that is playing the game is pressing one of the arrow keys. And we can determine that using the input axis. So inside of here, we're going to say if input axis does not equal 0. So if our input axis does not equal 0, we know that our character is moving, right? So we can say animated sprite 2D dot play, and then run. We know our character is moving, so we can play run. Else, our character isn't moving, animated sprite 2D dot play idle. Okay. Now we need to check if we're in the air. If we are, we want to set to the jump. So if not is on floor, animated sprite dot 2D play jump. Now this works because of the order. Because we're doing jump very last, it will override these animations. If we're in the air, it will override it and set us to our jump animation. Okay, if this was first right here, then these would override it and we would never ever see the jump animation. So that's important. And we're not seeing any of it, and it's because I forgot to call it. We need to actually call this function inside of our physics process. And come over here. Before move and slide, we can say update animations input axis. And now, when we run the game, our character is animating. The problem is they're always facing to the right. So we need to use our input axis to determine which way to face the character. There's two ways, click on the 2D tab. There's two ways that we can do this. One of them is by using the flip H property on the sprite, like this. We can use this property, flip _ H, to set the direction that the character is facing. The other one is to use the X scale, because if you do an X scale of -1, it'll also, they're linked together, so it did the Y as -1 as well. We'd have to unlink those and then do -1. You can see we can flip it. But I'm not really a fan. Well, honestly, it's fine to use either one of these, but in this case, I think it makes sense to use flip H. So we're going to do that. We'll come into our code here, and then inside of update animations, if we're moving, so only if we're moving, we'll say animated sprite 2D dot flip H is equal to input axis is less than 0. So if the input axis is less than 0, we know we're moving to the left, right? Input axis would be -1. So then we want to flip the sprite. If this is false, if input axis is greater than or equal to 0, which it can't be equal to 0, but if it's greater than 0, then flip axis will be false and we won't flip the sprite. And now you can see, got our character moving around inside of the world. Looks nice. There we go. Working perfectly. Now, there's one last thing I want to do, which is I want to set the background color so that it's black. And I think the easiest way to do this is to come into the ready function on your world, and we can access the rendering server, and it has a function called set default clear color, and we can set it to color.black. And that will make it so that right when the game starts, it will set the default clear color to black. And now we have a lovely little 1-bit art platformer. Okay. And one last thing, if we come into the project settings and then inside of the input map and then show the built-in actions, we can find our or actually, no, we just come into the player. And instead of using UI accept, we can use UI up. Now this switches to use the up key instead of the space key for jumping. So this is a personal preference if you like to do that. I think it feels more natural to me to use jump, but for some games it doesn't make sense to use jump. And you can set those though inside of project settings. You can set all of these different input actions, the built-in ones, to any keys that you want. You can create your own actions as well for binding inputs. So this is where you're going to handle all your inputs. You could also set this to work with a controller quite easily. When you come into an input action, say for example, the left key right here, you can click this plus, UI left, you can click plus, and then it will wait to try and listen for an input, and you can just input that on your controller and then press OK. You can get whatever key you want. It's really easy, super convenient. Okay, that's going to be it for this video. Hope you learned something and enjoyed it. I'm considering doing more videos in this series, fleshing out this platform controller character a little bit more. The idea would be maybe adding like a wall jump state, adding in some quality of life features like coyote jump, messing with the physics of the character a little bit to get the character feeling more nice, the movement feeling nicer. So if you're interested in that, let me know in the comments below. The big announcement that I had for the end of this video, I didn't forget about it, is that I know I haven't been here on YouTube recently. I've been absent from YouTube. I've been focusing on finishing my book, which has released digitally, and I'm working on the physical release now. And Godot 4 released. Yay, we're doing a tutorial on Godot 4. This is the first one. So because of the release of Godot 4, I actually went back and completely re-recorded the entire 1-bit Godot course in Godot 4. It's kind of like a remaster. I added new features to the course as well. And if you own the course, so if you ever purchase the 1-bit Godot course from my website, you get the remastered, re-recorded version completely free. Just go to the old course, and in the very start of it, in the first lecture, there will be an upgrade option where you can get the Godot 4 version completely redone, absolutely free. So if you've ever purchased the 1-bit Godot course, then go do that right now. I think the Godot 4 version is much better. If you haven't purchased it, I am doing a launch sale right now. So there'll be a link at the end of this video and in the comments below where you can go purchase the course at the discounted launch sale price. And I'm pretty happy with how it turned out. So thanks so much for watching this video. I hope you enjoyed it, and I will talk to you all later.